Welcome to you all to this virtual panel on the future of artificial intelligence. My name is Michael Tatham. I'm the Deputy Ambassador in the British Embassy, and I will make just a few introductory remarks before we launch into the panel discussion. It's a real pleasure for the Embassy to be hosting this event, the third of our Grand Challenges speaker series, and it's a pleasure to be doing so again in partnership with our friends in the National Science Foundation and with Axios. This event has been in the works for a while now. It was originally scheduled for December, then it was twice postponed, firstly because of the general election in the United Kingdom, and then because of the onset of COVID-19. So I'm really glad now that we've been able to reschedule and to adapt the event to a virtual format. As a passing comment, I think the way in which business and government have found ways of harnessing technology to adapt so quickly to this sudden plunge into a remote working environment is an illustration of the potential of new technology. Just as conversely, the sudden emergence of the pandemic and its tragic severity are very sobering reminders of the challenges and threats which, as societies, we still need to confront and for which we don't yet have easy answers. And I think one really interesting theme for today's discussion can be around the role of technology and of artificial intelligence in tackling the pandemic challenge. So as I said, the theme of today's speaker series is artificial intelligence. It is a timely and fascinating topic. It's an area in which there have been massive advances in recent years, and where these advances pose really fundamental questions about the potentially transformational impact upon our economies, our job markets, and on our societies as a whole. It's an area in which the UK government is investing in many ways, notably through education, to ensure that we have the right skills base to harness the potential of AI. The UK government's also considering the wider implications, including ensuring that AI developments are conducted to high levels of ethical standards, and that to the maximum extent possible, AI can become a force for good rather than the opposite. And in the UK, we have established the UK Office for Artificial Intelligence, whose head, Sana Khareghani, is one of our expert panelists this morning. Meanwhile, outside government, the UK is attracting high levels of investment into the AI sector. So against that background, the British Embassy is delighted to be hosting today's panel discussion, and we're especially pleased that we've been able to bring together a really expert panel to discuss some of the big questions around artificial intelligence. Our moderator for today's event will be Alison Snyder, a managing editor at Axios, where she covers trends and advances in technology, drawing on her background in both science and journalism. In a moment, I will ask her to introduce our expert panelists, who between them represent government, business, and the think tank academic community. So I think this sets us up for a great discussion. But before handing over to Alison, finally, I would like to thank everyone who has connected to today's event. We're very sorry that we're not hosting it in our ambassador's residence, as we've done with the two predecessor events, but we are very pleased that using this virtual format has expanded the number of people able to participate. And I can see that we're over 300 participants on the line. Welcome to you all. Thank you very much for taking part today. That is enough from me. Alison, could I hand over to you and invite you to lead the discussion? Thank you.
Thank you, and thank you to the Deputy Head of Mission, and thanks to the British Embassy and the National Science Foundation for co-hosting this event. You know, artificial intelligence is at the intersection of so many fields of science, different sectors of the economy, and big existential questions about society and humanity itself. You know, everyone from Elon Musk to the Pope has weighed in on AI and the future it may shape. So I want to thank everybody for watching. And before I introduce the panelists, I want a quick housekeeping note, which is to please submit questions for the panelists via the Q&A window. Include your name and your affiliation, and I'll pose them throughout the discussion. So turning to our panelists, I want to introduce everyone. First is Yolanda Gil. She's the president of the Association for the Advancement of AI and a professor of computer science at the University of Southern California. And then there's Saška Mojsilović, head of IBM Foundations of Trusted AI and co-director of IBM Science for Social Good. And then finally is Sana Khareghani, who's head of the UK Government Office for Artificial Intelligence. So thank you all for being here, for doing this. And I kind of want to pick up on something that the deputy head of mission said, and that is starting sort of where we are as societies and where we are with this technology. My first question is AI sort of meeting the moment in helping to fight this pandemic?
So I can get started. I think the AI community is very interested and very proactively participating in research to understand the disease, to understand the physical spread of the disease, to understand discussions in social media. So I can point to some examples from our institute. We have shared a large Twitter data sets, the data set about COVID-19, and we have shared it with the community. So there's many people using it and analyzing it, and we're looking at manipulation, public anxiety, the interplay between COVID-19 and the election. So I think social media gives us a window into the public's thinking and potential dangers of misinformation. So we're doing very active work in that area. We're also working on modeling the dynamics of the disease spread. So for example, our analysis show that if you look at mobility data in the network, it remains connected. So connections mean that the disease can continue to spread until almost all the interactions are removed from the network. So if you look at the network, until almost all the links for potential interactions are removed, the disease spreads to all the nodes, to all the individuals. And so we're very proactively looking at the literature in COVID-19, we're looking at social media, we're looking at models of the disease, and that's the case throughout the AI community, just speaking from a research perspective.
Sana and Saška, are there examples of ways in which it's being used successfully, and then I guess in ways in which it might be giving you pause?
Well, I think it's the. Oh, I'm sorry. Do you want to go ahead?
Go on, Saška.
So I think it's an important question because every time we look at a new technology like AI, we see really great examples of what it can do for us. And then we also see counter examples, and AI is not the first thing. And in a way, we are still learning because in the COVID case, people are coming up with some really new and innovative ways to use the technology, from surveilling the disease to managing to informing public. One example is, for example, contact tracing, where it kind of allows us that insight into who is around, is the work environment safe. On the other hand, we are collecting very sensitive data, the data that perhaps we may not be willing to share in any other situation. So this understanding of this trade-off between the benefit and the risk is going to be fundamentally important, because there is never going to be zero and white situation. There is never only just good or bad. And understanding the mechanisms that we can put in together as we develop these new technologies, especially the data-driven and private data-driven technologies, is going to be really important. And in understanding how we can quantify this trade-off between how many lives were saved and what are the risks that were mitigated with the risks of exposure of that kind of information.
I want to come back to that trade-off, but Sana, I'm hoping to hear from you a little bit about sort of ways in which you're seeing it being deployed, and you would like to stick around.
Sure, yeah, I can do that. Yeah, AI has played a really big role so far in the UK, and we feel that it's going to continue doing so as we prepare or kind of recovery, hopefully soon, out of the pandemic. So for example, we have a number of companies that, as Yolanda was saying, are helping to model the scenarios for what we call NHS-X, which is our kind of digital part of NHS, which is picking up and driving a lot of the work around the pandemic and around the kind of innovative technologies that have to do with health. Also, Google's DeepMind came out with AlphaFold, which was looking at kind of early protein structure predictions and parts of the virus. So they came out very quickly with this piece of work, and that's really been helpful. I mean, usually they take much longer to do that, and because of the pandemic, they came out very quickly with their studies around that to help improve how quickly we can find out more information about the virus. Benevolent AI automated literature searches to identify likely drug treatment candidates. So there's another really good example of that. And there's some indirect examples as well, I think, that are worth mentioning. So we have a company in the UK called SentryTech, which deploys EdTech. And it is freely offering EdTech now to whole countries to help kind of spread the necessary skills and make skills a little bit more available to children and to others that aren't able to access it as directly. Also, we've had just an absolute surge in online shopping, and grocery retailers were massively overwhelmed. But we had a lot of kind of retailers like Ocado, for example, who are well versed in the use of AI, who were able to manage this surge really, really well. So I think there's quite a few examples where AI has been really helpful, and there's others in countries like France, etc. The last one I'll end on, which kind of comes back to Saska's point around that risk benefit, that thinking between risk and benefit, is around contact tracing. So obviously one of the ways to help dampen the curve or bring that curve down is by understanding kind of who has connected to whom and when they've been sick, etc. And contact tracing is one of these apps that a lot of countries are using. And that question of your own personal data being used for the good of public, so something to compare your own data privacy versus kind of privacy of the whole, it means that a lot of these questions are being brought to attention rather than we have the time to kind of sit and discuss the ethics around data governance. We are now in a place where we want to deploy an app and we have to make decisions very quickly, and we have to start thinking about those the benefits and drawbacks of this. And the UK has a number of different organizations, the Centre for Data Ethics. We've now got another organization called the Ethics Advisory Board that are helping the NHS-X go through a lot of these questions and make sure that the use of data and what is being stored makes sense and lands properly within society.
So what type of data collection practices need to be put in place, either Sana or Saška, from your perspective?
I'm sorry, can you repeat the question, because I had a little noise on the line?
Oh, I'm sorry. I was asking what type of data collection practices sort of need to be put in place for things like contact tracing apps.
Well, so it's really data collection and data sharing restrictions. So it's important, for example, one of the very basic things is that data may not be stored for a longer period of time. The data has to be destroyed once the decision was made. The limitations to which data can be shared with third parties or whoever might be wanting to use that data. Another actually important area that we don't really think about very often is data protection from cyber hacking or model protection from cyber hacking, because AI models do tend to bring new levels of exposures that other type of software systems don't. So this notion of adversarial attacks on AI is very hot topic in the machine learning community. So the thought of data privacy, anonymization, all these kinds of new trends are going to be quite important in how we think about using data that is very unique to us and very personal.
Can I ask, oh, sorry, go ahead.
Pretty complete list. The only thing I would add to that is just is making sure that for whatever reason data is collected or used, that is the only reason for which it is collected and used, so that it isn't, we aren't going through a situation where we acquire consent to use data for a specific thing, and then actually once we've got that data, we use it for a bunch of other things as well. So I think that the kind of being very clear and transparent about what the data is, how it's anonymized, how it's being kept secure, and what is it's used for, and then how you get rid of it at the end is all very, very important along that.
And another thing that I would add is because it's not just the data part, it's also the system and application part. Because one of the things that we're not seeing today in the AI community enough is this notion of transparency, of understanding what a model or a system or application is doing. So, for example, about 2 years ago, we had a piece of work that was actually one of the first steps in the industry, called it the fact sheets for AI services, which says that you basically have, when you develop a system, it has to come up with some user's manual, right? When we go to a store and buy a device or a piece of electronics or you know, a kitchen blender or whatever, it comes with a piece of paper that says, well, this machine is doing the following, or don't use it in the following way. We don't see these kinds of things today with AI, and being able to disclose what the applications or models are doing, what kind of data they're trained on, how they are to be operated or not, how they're to be used or not, what are the kinds of applications or uses that are not acceptable, is really important. Because that's, in addition to data protections, it gives users and regulators and decision makers information to understand whether a model or an app or a system is really meant for a particular use.
Mm-hmm.
If I may, it's very interesting because I think there's also, as a society, as individuals, we don't have very good societal roles for AI entities in our society. So we have these personal assistants, but they are in these public rooms in a house where you may having a party or a gathering. There's a lot of aspects in which we have AI systems in our lives, and we don't have an understanding of their capabilities and their limitations. So when you walk into a company, if you talk to a receptionist, you know exactly what their role is. If you talk to the person that has, you know, the role of serving you coffee, you understand what the role is. But when you interact with an AI system, you don't quite understand, as Saška was saying, their limitations, their role, what responsibilities they can take on. And so I think that as a society, we need to evolve to a place where we understand exactly how the AIs fit and what things they're not appropriate for. And I'm working very closely with experts in communication here at USC that study when humans interact with AI, what kind of perceptions we form, what kinds of expectations we form, and they are completely different from what the manufacturers of those AI systems and the creators of those AI systems imagine they're going to be used like. So I think we have a lot of work to do with social scientists to understand how these AI systems, especially more autonomous ones, how they fit into our society and our business organizations and in general in our lives.
I want to take a couple questions that have come in because there's lots of them coming in. But first, I have one maybe for Yolanda, actually. There's a story this week in MIT Tech Review about how machine learning models were sort of trained on normal human behavior, and they're being tripped up by the dramatic changes in behavior they're seeing amongst us now, like particularly our purchasing behavior, right? We're buying like anomalous things like garden tools, and Amazon's adjusting its algorithm to sort of flip it to promote sellers that handle their own deliveries. So what does all this, I guess, tell us about the fragileness or the robustness of AI systems we have today?
So, you know, it's very interesting because we have been doing research in AI in universities for decades. And a lot of these things that are now being so interesting to the public are actually very well known and things that we are very well aware of, right? So this is an issue of the changes in the world around any system that has learned something, not just AI systems, but ourselves, right? As humans, if all of a sudden things change around you, you also change your behavior, right? And we are individually doing that in this pandemic time. But I will tell you that there was a project 20 years ago at Carnegie Mellon on an AI system that learned your calendar preferences. So it just watched how you set up meetings with students, with other faculty, the length of the meetings, if you tended to make them in the afternoons or on Fridays. And what it found very quickly is that in any given semester, it would learn to get better. And then at the end of the semester, the user would go into summer mode. And then the performance would go down because the system just did not know what was happening. Everything was different, right? And then back to the following semester, the students were different, the course was different, the priorities were different. So this is a very common problem. And I think it's not proper of AI systems alone, it's proper of humans as well. The challenge for AI systems is that we have much research to do to make them first realize that those changes are occurring. So today's AI systems are just happy continuing along, and they can't really tell if their performance went down so bad that it should stop making decisions and delegate. So we have a lot of work to do in noticing those changes and then behave accordingly and responsibly by saying, I'd rather not make recommendations because I have to learn what's happening in this new era and then learn from the new data and the new environment.
There's some.
If I can, yeah, I think there are also two very important thoughts here. We kind of like to think about AI systems as autonomous, you know, they're going around and doing their own thing, while in reality, we should really be thinking about how do we use them as helpers to augment our decision makings and help us be better in what we do, because there is a big difference in autonomous and augmentation. The second thought is also the notion of AI governance, which is also a part of responsible development of an application or a system, which is there could be safeguards, because again, these systems don't run on their own. We have the ability to sense when the conditions in the environment have changed, when the data stops looking like the data that the system was trained on, so that we can detect what we call the drift in the decision making. And then now we know that the system is less confident in how it's acting or making decisions. And that all of that has to become a part of the solutions that we create. We have, for example, several projects that looked into how do you arm a platform or an AI lifecycle with these kinds of detection and safeguard capabilities, so that when it runs, it doesn't go rampant or it doesn't start behaving out of whack, because you can sense that there is a change and maybe you are not so confident in its outcome anymore.
Sorry, there's so many good, terrific questions coming in. So I want to ask two related to the coronavirus pandemic, and then we'll move on to some others. But two questions. One is, what will be metrics for success in the application of AI to the COVID situation and in general to sort of other challenges? And then the second question is from David. What areas of AI do you think will have accelerated adoption because of the societal changes happening because of the pandemic? If you each want to.
Can I start off by just saying, and giving a couple of examples of things that we've seen. So we have pushed quite hard, you know, for kind of uptake of digital and diffusion of AI technologies and so on in a safe and responsible way. And one of the results that we have seen is this acceleration of the use of technology and of digitization in this time. And I think there is something about the necessity of its use and the fact that it's kind of just making it easier for people to connect and get together and do their work. But as a very concrete example, We have the ability to use online GPs, which is your doctor. Here used to sit around 2 or 3%. It's recently gone from that to over 85%, and that it's done that within a couple of weeks. And that adoption rate has never ever before been seen. And obviously these kinds of systems have AI technologies embedded within them all over the place that help kind of route you towards the right person to speak to, and all sorts of kind of triaging things embedded inside. So it's incredibly these kinds of things are incredibly amazing. Also, it's the use of things like predictive text and text to speech, and some of the technologies that, you know, have previously been created in order to help everyone access digital technologies. The use of those is also increasing. Moreover, I think there's this question as we all move to working from home is about how do we continue using, and what are the new types of technology that we need, and the new kinds of innovations that we need going forward to make what we're doing now better, easier, more efficient, more productive. Because some of our usual ways of working are not as easily done, right? And it's not always the technology and the kind of devices that we have don't lend themselves as nicely as we would like to be able to do the work that we're trying to do from home or from wherever it is that people are doing the work. So I think there is this massive kind of influx of use and digitization that is incredibly important there, that we should build on and move from. And the technologies that are being used and the adoption rate is out of control on some of the areas that, you know, has been a great move towards, you know, something we've been waiting to see for a while.
But in that context, I guess, are there concerns that in the urgency of this moment, like that concerns about the tech might be overlooked?
So, you know, this is, I think there is I think what this shines a light on is the importance of continued research funding. So one of the other things that we push on and try and make the point about, especially in the Office for AI, in terms of kind of what does government do, where does government prioritize, is about continuing to fund research in AI technologies, in safe and ethical AI, in transparency, in resilience, in a lot of the things that don't seem as shiny or interesting when you look at applications, but actually are incredibly important when it comes to using these technologies across the whole of society, right? So I think one of the things it's done is actually back up a lot of the cases that we've been making in the past in terms of why should we be continuing to fund things like safe and responsible AI? Why should the UK continue to lead in safe and ethical AI research? And the pandemic and what we have seen as technology's role, you know, the central role that it's played in keeping us connected and keeping the economy kind of churning, makes that point better than we could have ourselves.
I wanted to add something, because I think that one of the things that we've seen with this pandemic is the need for accelerating scientific research so that we can find vaccines, so that we can find treatments. And I have been working for a long time on using AI to understand scientific discovery processes and try to help scientists be more efficient in those processes. And so we always talk in theory, we say, you know, we can use AI to accelerate our understanding of the environment and sustainability, but we've got time. Or we can use AI to find, you know, discover more things at the genomic or molecular level, but, you know, we've got time. And what we see here is that if we've really succeeded at embedding AI assistance into every scientific laboratory, the efficiency would be much higher, and we would be able to get to, you know, discoveries and better understanding of complex aspects of something like coronavirus faster. Not that AI will solve all the problems, but I'm saying that what we're seeing with this pandemic is that there is really an urgency to use AI to help in scientific discovery and scientific understanding.
If I can chime in here, because I think this is it's not just the way that it's going to accelerate how we make discovery, but it's going to profoundly change the process of making discoveries because of all the new tools and all the new ways to use AI to find new stuff. I'll give you an example. We have, for about 2 years now, we've been working on generative models, AI generative models, like, things that can create images and fake news. But we thought, what if we can teach AI to create new molecules and new materials? And how about we can do it in a way that is very robust? So for example, for a long time, we were working on a problem of antibiotics. But then when the COVID came, within a week, we were able to improve the system to create completely new molecules that can be drug candidates for COVID. And what's really interesting now, this type of discovery changes also who can advance these systems, because we can now partner with universities, with independent labs. We can run challenges around these created molecules. We can team up with partners to use high performance cloud so that somebody else can run simulations. So suddenly we have these communities of discovery, and it's a complete disruption of how we are going to be creating things in the future. So I think the big lesson learned from COVID, we may not be able to find a drug today, or maybe in a couple of weeks, we might be, I don't know, I'm hopeful. But one big, if I can use the word win from all of this, is that we now have a potential to reuse all of these technologies and all this knowledge and the patterns that we learn to address the pandemics of the future, or new disasters, or disasters that might happen in the future.
Totally couldn't agree more. I think that building of resilience as we go forward is enormous, and this collaboration, that's I couldn't agree more. An international collaboration across countries on something that is indisputably a focus for everyone, right? Whether it's investment or it's our scientists or whatever it is, it's a focus for everyone. This is the most global moonshot we've ever had, right? And as a cause of this, the kind of structures that we build for collaboration across boundaries and all that kind of stuff is one of the things that I hope is going to get written down and documented, and we can learn from it and make it better, and make ourselves as a world more resilient to whatever quote unquote war comes next.
I want to make sure we spend some time talking about bias, which is a huge issue in AI, and basically that algorithms that are used for hiring and underwriting loans and policing and setting bail, all these things have raised concerns about this issue. And it seems like there's sort of two camps. There are the people who think that bias can be removed with math and or addressed in these decision-making systems, and then there are those who think that AI just shouldn't be used for making high-stakes decisions. I'm curious which camp you all are in, and well, let's start with that. Which camp are you all in?
I can start really, because I think it's hard to say the camp, because I think the bias can be controlled, and I think it's really important to understand that the bias does not come from a machine, because the machine is a piece of something, a code that we create. Bias oftentimes, most of the time, comes from us, because it's encoded in our behaviors, in our decisions, and eventually the data that we create. So once we recognize that, then it helps us understand the processes and methods and ways that we can overcome it and mitigate it in AI solutions that we create. And that goes, there are many elements to that. Some of them are based in technology. Some of them, like we do have algorithms that can detect bias in data. We do have algorithms that can detect bias in other algorithms, even remove it to some extent. But that's not enough, because these these solutions that we create are really always going to be working with humans and are going to be applied to real problems. So another important part is really the understanding of, what are the kinds of problems that we want to solve with AI? How is AI going to be applied? How is AI going to be used? Where is the potential for harm and damage? And that can only come also by understanding that these are not just technical systems, but socio-technical systems, and working with all stakeholders to mitigate risks from all sides. So I would say in a camp one, I'm a big believer that these technologies can be used in a controlled way, and by doing so in a way even help us be better, because we are not really perfect to start with, unfortunately.
I want to say that we often have a very anthropomorphic view of the world, and we think that us as humans, we can make decisions, we do things properly, and humans are incredibly imperfect in so many ways. So outside the door of my office, I have posted an article that shows that judges make the harshest decisions right before lunch. Right? So as humans, we have so many imperfections, and biases is one of them. So we somehow, when we judge machines, we hold them to a much higher standard, right? And we want them to do the right thing. And oftentimes we can't even say what the right thing is. So there's a lot of work on interviews of people regarding how would they like autonomous cars to make decisions. If they're driving on a road and there's somebody crossing and they cross all of a sudden, maybe a kid running, and then the car could autonomously just veer right, but there's some group of people there, and so they might get harmed. So when you ask these questions to humans, the answers that you get are not a logical, consistent set of answers. So humans ourselves, we are extremely unclear when it comes to bias, when it comes to justice, when it comes to fairness. And I tell you that my priority, as important as it is to make AI systems fair and unbiased, my priority is that by doing this research in making the AI systems better, that we learn to be better humans, that we will understand, identify, and correct our own imperfections when it comes to making judgments and making decisions. We've been using AI systems for allocating loans in banks for decades, since the 80s, right? So these issues have been around for a long time, and I think that people are more aware now, and of course AI is much more pervasive. But I think I'm hoping that this research in making AI more fair and unbiased will make us realize that we have a lot of work to do ourselves and make a better society.
Totally agree. I think one of the things that AI technologies have done is hold a mirror up to us and show us the bias that we as humans have. So I think, yeah, I totally agree. We hold machines or kind of technology to a higher accountability than ourselves. But I think there's something else in there that that Saška was talking about in terms of, there's different bits to this. There's a technological solution. So absolutely there is. If you give a mathematician what the equation, what the weightings of fairness is, they can put that into the system for you. That is very easy. And you know what? That will be the least biased system you will ever get, because it will always make the decisions in exactly the same way, whether it's before lunch, after lunch, in the morning, in the evening, right? Doesn't matter. It will always make those decisions. But the key question is, who's got the weightings right? Right? And so a big part of this, when we're trying to have, and again, I think it's really hard to talk about this in generalities, you have to think about context specific, but when we're starting to create these AI algorithms that affect the whole of society, we need to be representative of that society, right? So I love the fact that on this panel, including our chair, are all female. That is not representative of the AI researchers domain, right? It just isn't. But it would be great if we became much more representative of the society whose problems we're trying to solve, right? Because my truths and my life lessons have been very different from everybody else's. And unless you're able to kind of think about that, you're not able to see all the solution sets, and you're not able to see the bias in your own system. So, you know, it isn't only a technological problem that can be solved with technology. We need to have some of these thoughtful discussions, right? And the trolley problem that Yolanda was talking about was never meant to be, never meant to have an answer. It was meant as an ethical question that doesn't have an answer. In fact, in humans, if you ask a driver, would you kill this person or that person? And if they choose, they're guilty. Right? The kind of, the act of choosing makes you guilty under the law. So there isn't a right answer for this, right? That isn't the way to approach it. So I totally agree. We need to do more research. It's very context specific. We need to spend the money in figuring out how the human becomes the center of that loop, how we shine a light on all the bias and the decision making that we do badly all the time. And then hopefully we can make progress.
So 2 questions from the audience and then 1 from me. So the first question from the audience is from Richard Boyd, who asked, he says, in the US in 1800, 91% of everyone was involved in agriculture. In 1900, it was 41%. Today, it's 2%. So we had 200 years to adjust to the industrial age. But now we need to adjust in 5 to 7 years. What can be done from a policy perspective to ease the social tension of this adjustment?
So, you know, I'm not originally from the US, and what brought me to this country is opportunity. I think it's a country of invention and opportunity, and I hope that our society will see opportunities and innovations and a way to move ourselves forward with AI. So what I see is opportunities to have a lot more AI engineers that will understand how to adapt AI technologies for the many domains and the many specific contexts where they can make a difference. So I was working this week with people from our School of Social Work looking at foster children. There are 5 people trying to use AI for this problem in the world. How can we augment our ability, our capacity to apply AI technologies more pervasively and more thoughtfully in ways that are appropriate to the context and the domain? That requires an army of AI engineers that may not necessarily develop new AI algorithms, but understand them and know how to apply them properly. So I see a future where you know, all of those farmers learn to become something else and do something else. And today there's a lot of robots doing farming, and there's a lot of more industrial approaches to farming that may be more efficient. So I think of all the opportunities that AI is going to do to create jobs. Data engineers, an incredibly hard job. If we had a lot more data engineers in the world, we would be able to use AI much more pervasively for many more problems to improve everybody's lives. I also think that AI systems are going to become commercialized with many different gadgets, many different things, and there's room for AI customization. So how do you take 7 gadgets, make them all work together so that their decisions are coordinated? Or, you know, I buy this gadget, this robot, but in my house, I want it to work in a certain way. How will that happen? So I think that in the next 10 or 20 years, you'll see a lot of AI customization opportunities, robot repair. So I think we have to understand those jobs, and already they're in very high demand. We cannot graduate data scientists fast enough in my university, and I know in others as well. So we have to give the education and the training that is needed to propel these technologies forward and help us go through those 200 years, but in a more compressed time frame.
One more question from Professor Stephen Mears, the head of the AI lab at the UK Defence Science and Technology Laboratory. He says there's no universally accepted definition of AI, and it's often used as a byword for all sort of digital technologies. What do you believe is the right balance between not being overly prescriptive about how we define AI and AI being all things to all people? And how do you sort of promote a conversation without people talking about fundamentally different things?
So can I have a go at answering this, because this is kind of my everyday problem. I first of all stop people from using the word AI on its own. I refer to it as AI technologies. I make sure that people understand that AI isn't a sector, but an ecosystem. And we talk about kind of what the bits of the ecosystem are that come together. And then, and most importantly, is one of the things I've already said, one of the things we talk about all the time is context. So are we talking about an AI technology or system that runs the heating in an office and what data that needs? Or are we talking about, you know, how to prioritize patients in NHS, right? So where are you on the data spectrum, right? When you're talking about this, how pervasive is this information? You know, how much sharing and connecting do you need to do? What are all the questions that you're you know, faced with in doing this? I also I think it's really important to show quite how big it is. There is and finally I'll just end on this and so that others can speak, is that Geoffrey Hinton, who, you know, a lot of people think of as the godfather, or at least one of, he says that, you know, today's AI is just tomorrow's computer science, right? So when these technologies become pervasive enough and mass used enough, they're not referred to as AI anymore. They're just software, right? And so I think that is a really important distinction, and I think that context is hugely important.
So last question about the sort of the culture of AI and computer science is more broadly, it's just a very open and collaborative one. And yet AI, along with technologies like 5G and now vaccines, are sort of seen as national competitive advantages that are tied to national security. How can that be reconciled going forward? What are the areas for collaborating, particularly between the US and the UK?
So I just came from a meeting in London, the last trip that I did at the Turing Institute, and Turing perhaps is the godfather of AI. He defined what's called the Turing challenge of whether, I guess in short, a computer could fool someone in thinking that it's a human. And we worked across different, you know, scientists from different countries to create a global effort to create AI scientists that can do Nobel quality research by 2050. So this would be a global initiative trying to pull together international resources and international talent to really work towards improving the way that we do science using AI. And I think that's very important. We held our national conference in AI also in February here in the US, and we had about 800 participants from China that were unable to come and canceling the last minute. And I can tell you that just watching people come together, either sending videos, connecting remotely at 3 in the morning, asking questions even though the speaker had not been there in person, and just seeing the community on how at the science level we are all connected. And I'll say that I really admire Bill Gates. He was asked a question recently and he said, last time I checked, AI is a human problem. It's a human problem. We need to use AI to understand thinking and reasoning. We need to use AI to solve real societal problems like health and the environment. So can we come together at those levels? So I think at the research level, at least, the research community is very much intertwined across Europe, across Asia, and a lot of the problems that we're tackling with AI, and COVID-19 is a great example, deserve international collaboration.
I have to agree. I agree. There's a, you know, there seems to be a race, but it's not from a government perspective. We very much believe in international collaboration, and we build MOUs and share best practice with like-minded nations across the world. And we work very closely with the US, we work very closely with a whole host of countries in Southeast Asia and in Europe. China included, in terms of making sure that we are connecting our scientists, because that best practice is really hugely important. And the companies themselves don't have boundaries by international boundaries anymore. And governments too need to be able to share policy advice with each other in order to be able to approach the right answer in a quick enough time frame. So, I mean, a couple of examples are that there's G7, G20, the OECD, but also the World Economic Forum does a huge amount of connecting across countries. And we've been working with the World Economic Forum, for example, on creating AI procurement guidelines, which we'll be publishing soon, which is one of the things that we feel is really, really important. So if you've got, in the public sector, you need to, in order to allow diffusion of AI technologies, you need to allow procurement experts who don't know anything about these technologies to ask the right sets of questions, to know who to go to in order to find out whether or not a decision they're making in purchasing a certain piece of software, how that's going to adversely affect others, so that they're asking the right set of questions in order to do that. And we did that with the World Economic Forum, and we worked across a whole number of countries and international companies in order to test the guidelines and develop them. So I think international collaboration is enormously important in this area.
All right. I think we're out of time, Saška, unless you wanted to weigh in about this.
Yeah, I can just briefly chime in and just say that the nature of scientific research and exchange of results in AI is so incredibly open these days, because of the way we publish, because of we prefer to publish in open journals, present at conferences that are largely international. So it's getting really increasingly difficult to create that differentiation between in the climate where sharing results, replicating code is open. It's getting tough. So I think to some extent market and the nature of scientific research are going to correct for these competitive behavior.
Well, thank you all so much. It was absolutely fascinating. Thank you to everyone for watching as well. And I think and thanks again to the British Embassy and to the National Science Foundation. And I hope everyone has a good rest of your day, and stay well.